time is relative, so too is accelerating in the perceived energy temperature of the universe. The Big Bang is an illusion created by the measuring space-time in 3D measurements. Just as time is relative, so too is accelerating in the perceived energy temperature of the universe. The Big Bang is an illusion created by the measuring space-time in 3D measurements. Just as time is relative, so too is accelerating in the perceived energy temperature of the universe. Within in this singularly, technically zero dimension, as we zoom in or out in new dimension, it appears to expand alongside its own consciousness. It is both dead and alive until someone outside the closed system tries to measure it. From most of our points of view, it appears to be changing temperature and acceleration. Within in this singularly, technically zero dimension, as we zoom in or out in new dimension, it appears to expand alongside its own consciousness. It is both dead and alive until someone outside the closed system tries to measure it. From most of our points of view, it appears to be changing temperature and acceleration. Within in this singularly, technically zero dimension, as we zoom in or out in new dimension, it appears to expand alongside its own consciousness. It is both dead and alive until someone outside the closed system tries to measure it. From most of our points of view, it appears to be changing temperature and acceleration. Within in this singularly, technically zero dimension, as we zoom in or out in new dimension, it appears to expand alongside its own consciousness. It is both dead and alive until someone outside the closed system tries to measure it. From most of our points of view, it appears to be changing temperature and acceleration. Hypercube from Wikipedia, the free encyclopedia. This article is about the mathematical concept. For the film, see Cube 2, Hypercube. For the computer architecture, see Connection Machine. Perspective projections. Cube, 3 cube, tesseract, 4 cube. In geometry, a hypercube is an n-dimensional analog of a square, n equals 2, and a cube, n equals 3. It is a closed, compact, convex figure whose one skeleton consists of groups of opposite parallel line segments aligned in each of the space's dimensions, perpendicular to each other and of the same length. A unit hypercube's longest diagonal in n dimensions is equal to. An n-dimensional hypercube is also called an n-cube or an n-dimensional cube. The term measure polytope is also used, notably in the work of H.S.M. Coxeter, originally from L. 1912-1, but it has now been superseded. The hypercube is the special case of a hyperrectangle, also called an orthotope. A unit hypercube is a hypercube whose side has length 1 unit. Often, the hypercube whose corners, or vertices, are the two endpoints in a ring with coordinates equal to 0 or 1 is called the unit hypercube. Contents: height 1, construction 2, coordinates 3, elements 3.1, graphs 4, related families of polytopes 5, relation to n symbolizes 6c, also 7, notes 8, references 9, external links, construction, edit. A diagram showing how to create a tesseract from a point. An animation showing how to create a tesseract from a point. 0. A point is a hypercube of dimension 0. 1. If one moves this point 1 unit length, it will sweep out the line segment, which is a unit hypercube of dimension 1. 2. If one moves this line segment its length in a perpendicular direction from itself, it sweeps out a two-dimensional square. 3. If one moves the square 1 unit length in the direction perpendicular to the plane it lies on, it will generate a three-dimensional cube. 4. If one moves the cube 1 unit length into the fourth dimension, it generates a four-dimensional unit hypercube, a unit tesseract. This can be generalized to any number of dimensions. This process of sweeping out volumes can be formalized mathematically as a Minkowski sum. The d-dimensional hypercube is the Minkowski sum of d mutually perpendicular unit length line segments, and is therefore an example of a zenitope. The one skeleton of a hypercube is a hypercube graph. Coordinates, edit, a unit hypercube or whose dimensions is the convex hull of the points given by all sign permutations of the Cartesian coordinates. It has an edge length of 1 and an n-dimensional volume of 1. An n-dimensional hypercube is also often regarded as the convex hull of all sign permutations of the coordinates. This form is often chosen due to ease of writing out the coordinates. Its edge length is 2, and its n-dimensional volume is 2n. Elements, edit. Every n-cube of n greater than 0 is composed of elements, or n-cubes of a lower dimension, on the n1 dimensional surface on the parent hypercube. A side is any element of n1 dimension of the parent hypercube. A hypercube of dimension n has 2n sides. A one-dimensional line has 2n points. A two-dimensional square has 4 sides or edges. A three-dimensional cube has 6 two-dimensional faces. A four-dimensional tesseract has 8 cells. The number of vertices, points, of a hypercube is, a cube has vertices, for instance. A simple formula to calculate the number of n2 faces in an n-dimensional hypercube is the number of n-dimensional hypercubes, just referred to as n-cube from here on the boundary of an n-cube is, wherein n denotes the factorial of n. For example, the boundary of a 4 cube, n equals 4, contains 8 cubes, 3 cubes, 24 squares, 2 cubes, 32 lines, 1 cubes, and 16 vertices, 0 cubes. This identity can be proved by combinatorial arguments. Each of the vertices defines a vertex in a dimensional boundary. There are ways of choosing which lines, sides, that defines the subspace that the boundary is in. But each side is counted times since it has that many vertices. We need to divide with this number. This identity will generate the informations of the n-dimensional cube surface area, the surface area. More specifically, what would be the implications for questions can also be generated by the linear way to think about the implications would be by asking the following questions: where could we still be free even if scientists were to discover causal determinism a square with determined vertices adds 1 extra line, edge, per vertex, and also adds the final second square. To form a cube stands given equals 12 possibility of time travel. Hypercube time travel is possible. Sequence A013609 in OPIS, but you cannot literally small letter gamma 0. Consider the following argument point. The proposition Lincoln was assassinated in 1865 is true. If Allison traveled to the past, she could prevent Lincoln from being assassinated in 1865. Temporarily assumed for reductio purposes. If Allison were to travel to the past and prevent Lincoln from being assassinated in 1865, the proposition Lincoln was assassinated in 1865 would be false. 12. A proposition cannot both be true and false. 4. Therefore, small letter gamma 4 cube tesseract octocoron 4 3 3 16 32 24 8 1 5 Greek small letter gamma 5 cube pentaractecadron 4 3 3 3 32 80 80 40 10 1 6 Greek small letter gamma 6 cube hexaractodecapedon 4 letter gamma 7 cube heptaractetradeca 7 tope 4 3 3 3 3 3 128 448 672 560 280 84 14 1 8 Greek small letter gamma 8 cube octo